Damn, Danielle, this is torque. I will be able to understand the concept of torque and how it relates to real-life situations, take notes on a video, practice problems with peers, and perform an activity with group members. The definition of torque. Torque is defined as the tendency to produce a change in rotational motion. Torque is proportional to the magnitude of force and to the distance r from the axis. Thus, a tentative formula might be torque equals force times the radius. So the units is Newton meters or pounds per feet. So in this example, we have a 40 Newton force and 6 centimeter long wrench. So we change that into meters, turns into 24 Newton meters. And yeah, clockwise that is, sorry. Torque is determined by three factors: the magnitude of the applied force, the direction of the applied force, and the location of the applied force. The forces closer to the end of the wrench have greater torque. So location of force, we could have 20 newtons at the end, 20 newtons in the middle, or 20 newtons closer to the opening of the wrench. So direction of torque. Torque is a vector quantity that has direction as well as magnitude. Turning the handle of a screwdriver clockwise and then counterclockwise will advance the screw first inward and then outward. So our sign convention for torque. By convention, counterclockwise torques are positive and clockwise torques are negative. So counterclockwise positive, clockwise negative. So we will put this one in as counterclockwise, and this is positive torque, and then this is counterclockwise, so this is negative torque. So just like everything else, we're going to read a problem, we're going to draw a rough figure, extend the line of action of the force, draw and label the moment arm, calculate the moment arm if necessary, and apply this. So here's our first example. We have an 80 Newton force acting at the end of a 12 centimeter wrench as shown. We're going to find the torque. So here's our picture, our wrench at 12 centimeters, 80 newtons at a 60-degree angle. So we have to draw this 90 degree, and the 60 is right here, and our radius is still 12 centimeters. So r equals 12 centimeters times sine 60. So that gives us 10.4 centimeters. So the torque is 80 newtons times 0.104 meters, which is the same as 10 centimeters, or the 10.4 centimeters. So here's another problem. So we will resolve the 80 Newton force into components as shown. So just like we did before with inclined planes, we have this force and this one giving us 60 degrees. The force is 80 newtons. So if we do this one, this is going to be the sine. So that would be our F in the Y direction. So that's 69.3. And then we would do this one for cosine, and that would give us 40 newtons. So it gives us the same thing, but we're just trying to figure out this way. And actually, I like doing it this way better. And that's it. Enjoy.